Hello! This video is an overview of the ultrasonic electronics kit for Raspberry Pi by Freenov. I bought this kit on Amazon for about $45 Canadian. You can also buy it directly in the Freenov eBay store. Documentation is available through a download from the Freenov website. The manual is very comprehensive. It has over 250 pages. It offers an introduction to Raspberry Pi basics. It details the electronic components included, and there are coding examples for multiple programming languages, including C and Python. Having said that, I find the documentation too overwhelming for the beginner and the code overly complex and outdated. If you are just starting with Raspberry Pi, this is a great foundation, at least in terms of the physical goods. The kit is good value, it comes in a nice storage box, and it has a good selection of components inside. Let's have a look at it. Here's a handy resistor code card. A small servo motor. This one connects directly to the Pi as the controller is integrated. A bag with small components, LEDs, push buttons, capacitors, photoresistors, etc. This ribbon cable is used to connect the breadboard to the Raspberry Pi. The breadboard has several components attached for shipping purposes. They need to be removed before you make your first project, with the exception of the cobbler connector. This is a small relay, a power supply capable of providing 3.3 and 5 volts. It's sometimes used to energize the breadboard power rails to provide sufficient power for DC motors, as the Pi cannot power such motors directly. Several composite LED components, a standard 7-element display, an 8x8 matrix, and an LED bar. They are fun to work with. A couple buzzers, one active and one passive. 3 integrated circuit chips, 2 shift registers, and 1 bidirectional DC motor controller. This is an LCD display. This particular model works great with the Pi, as it only needs 4 wires to connect. Here's the ultrasonic distance sensor. This entire kit is named after this component. This is a standard 5-volt DC motor. It's used with the controller chip found on the breadboard. A stepper motor with a matching controller. Whole bunch of jumper wires to make breadboard connections. A 9-volt battery connector. This one is used with the breadboard power supply. Three old-school potentiometers. They're essentially variable resistors. A resistor pack with several resistance values. And here is an analog joystick. The last component is an analog to digital converter. This is an 8-input chip. It's used with potentiometers, thermistors, the joystick, etc. I suggest storing the components in the box they came with, but protect them from static electricity. Particularly, the IC chips are sensitive to that. Make sure to remove the chips carefully from the breadboard. Use a flathead screwdriver to gently lift alternating sides, making sure not to bend the pins. As I said, static electricity is your enemy here. I actually have an anti-static mat on my workbench, and I'm also wearing an anti-static wristband. If you don't have that, make sure to touch a metal surface before handling integrated chips. Use an anti-static foam to store the chips. You can cut the foam to fit the box. Take care when you push the chips into the foam, making sure not to bend the pins in the process. That's about it. I have a number of videos available on my YouTube channel aimed at beginners, which provide an introduction to most of these components using Python and C. Check it out, and don't forget to subscribe. Thanks for watching.